Hey guys, so today we're going to be moving a little bit more forward with properties of logarithms. So now we've already touched base. I've sent you some videos and other lessons last week on logarithms. So today this is considered properties. So just like you had properties of exponents, you have properties of logarithms, and they're very similar from each other. So what I have here on my notes here, okay, I have our title, properties of logarithms, okay, and there are three different properties that we're going to be working with today, okay. So let's look at the first property, and if you want to write this down on your own, definitely do that if it helps you. Okay, so the first property is called the product property. So it's just like the property in exponents, product property. So we have log base b, because that's how we say it, log base b of mn. Okay, mn are connected by multiplication, and another word for multiplication is product. So what was our rule back then when we were doing properties of exponents with product, with multiplication? We had addition. So in order to move forward with log base b mn, that would be equal to the log base b of m plus the log base b of n. So you're just separating the m and the n by a plus sign, an addition sign. So for multiplication, you add. Now your second property is quotient. Quotient means division. So when we had division, what did we use in exponents? Subtraction. So if you have log base b, m over n, it really is equal to log base b, m minus log base b, n. Okay? And then finally, your third type of property is called power. Okay? So what that is when you have log base b, okay, you have a number raised to an exponent, m to the n. So what the property rule for that is taking that exponent and putting it in front of the log. So that's what I have written here. It turns into n times the log base b m, whatever m is, okay? So what I have here below are some examples on how to use these properties, okay? Use these three properties for three different examples. So our first example is going to be log base 6, 5 over 8. Now in my directions here, my little starred directions here, it says use log base 6, 5, which is about this decimal. So you're going to need to use your cell phone, or if you have a calculator at home, that's fine. But if when we get heavier into logs, you have to move your cell phone horizontally so you can get those fancy buttons like we have in class on the calculators. But this is already given to you, okay? So for log base 6, 5, you're going to use this decimal number, 0.898. And log base 6 of 8 is equivalent to 1.161. Okay, so we're going to use that number. So looking at our first example, we have log base 6, 5 over 8. This is considered what type of the rules? The first, second, or third? Well, it would be the second, quotient, the quotient rule. Okay, you have division here, you need to use subtraction. So this is going to be equal to log base 6, 5 minus, because that's the rule for quotient, log base 6, 8. Okay? And you were already given in the directions what those numbers are actually. So log base 6, 5 is what number? 0.898 minus, what's log base 6, 8? 1.161. And all you have to do is with your calculator subtract these two numbers together. And what answer do you get? Negative 0.898. 263. That's your final answer by using the property. Let's try another example. Now we have log base 640. Now for this type of example, using these numbers, 5 and 8, what can we use? What do we know about 40 that's in relation to 5 and 8? Well, guess what? Okay, 5 times 8 equals 40. So this is a multiplication problem. This is log base 6, 5 times 8, which really equals 40. So since this is multiplication, this turns into log base 6, 5 plus product, quote, product multiplication addition, log base 6, 8. Do we know how much log base 6, 5 is? Yep, that was in our directions here. That's 0.898 plus 1.161. And what answer do you get for that one? When you add those two together, 2.059. Done. So we did an example of product, quotient, and now what do you think this last example is going to be? Power. This is your power. So we need to use either log base 6, 5 or log base 6, 8 to get in relation to 64. Well, 5 isn't going to give us anything by using the power, meaning 5 raised to a power is not going to give you 64. But what about 8 raised to a power? Okay, well, guess what? That works. So if you have log base 6, 8 raised to what power, that will give you 64? 2. 8 squared is 64. Okay? So how do you rewrite that based off of the property? You take the exponent, okay, bring it to the front, 2 times log base 6, 8. But you already know the value of log base 6, 8, which is in our directions here. So this turns into 2 times, parentheses, what was log base 6, 8? 1.161. Multiply that number by 2, and you get 2.322 as your final answer. So here are 3 different examples that use the 3 different properties for logs that are also connected to properties of exponents. So let's move forward to the next piece. Our next piece is talking about expanding log expressions. Okay, so what we're going to do with this example is we're going to write this out, expand it. Not necessarily solve with decimals and everything like that, like we did in the other last 3 examples, okay? But this is just an expansion, okay? But you also need to know your properties from what we just did, okay, in order to expand this. So in order to expand this properly, we have log base 6, 3x to the 4th, okay? How is the 3 and the x connected? By what operation? Well, guess what? Multiplication. So that was your product rule from what we just did. And what's the rule for product? Addition. So we're expanding this to log base 6. What's the first value? 3 plus log base 6 x to the 4th. That's one expansion. We're fully expanding this by using our 3 properties that we were just doing, okay? So we're using addition because we had 3 times x to the 4th. 3 times x gives you addition. When you have multiplication, you add. But now we can expand this a little bit further, this part. This is your power rule, where you have a number or variable raised to an exponent. So in order to expand this, what did we learn in the previous example that this exponent goes in the front here. So our new expansion is, we didn't touch this, this is done, log base 6, 3, okay, plus bring this exponent to the front here, 4 times log base 6x. And that's it. That's how you expand. You're using your properties that we were just working with to expand our log. Okay, so now that is fully expanded. Now we're going to go to the next one. Now we have ln 5 over 12x. Now ln just stands for natural log, okay? So, but you're still using the same properties. So if I have ln 5 over 5 divided by 12x, division, which equals the quotient property, which equals subtraction. Okay, so we are subtracting. We have ln, what's the first value? 5. And for quotient, we have to minus ln 12x. That's the rule, minus. So I don't know, it looks like we would be done, but technically we're not. We can break this ln 12x down. What can we break it down to? Well, what's the relationship between 12 and x? Multiplication. So what's the rule for multiplication? Addition. So now we have ln 5, that's done, minus ln 12 plus ln x. Plus comes from the multiplication. Can I do anything else with that? Nope. So that's your final answer. Done. Okay. So what we had here is we were expanding a log expression. We were making it longer, stretching it out, bigger. Now, our next two examples are condensing, where it's already expanded and now we're going to do the opposite, bring it in with our properties of logarithms. Okay, so what we have here is we have log x minus log 9. What does the minus tell you? Minus tells you what? Division. It tells you another word for division is quotient. So that means we're going to have the log of x over 9. Can I do anything else with that? Absolutely not. That's your final answer. You just condensed the expression by using the property of quotient property. Then we have our final example down here. See how this is all expanded? Well, now we're going to bring this big one all together in one piece. Okay, so I can already tell you all three properties are in this one problem. So we're going to do a piece by piece. Okay, we have addition. That means it's the product property. We have the number in front of the natural log. That means the power property. And we have subtraction. That means the quotient property. Okay, so let's go from left to right. Okay, we have ln 4. Now, addition means it's times this piece. 3 to the third power, all over 12. Okay, this whole natural log, ln, belongs to this entire piece. And I put it over 12 because we have subtraction. So now we have to clean this up a little bit better. We have ln 4 times, what is 3 cubed? 3 cubed is 27 over 12. Okay, what is the next piece of cleaning up we have to do? 4 times 27. What is 4 times 27? 108 over 12. Then you need to check, you have division. Can you divide these evenly or reduce it? Simplified to its simplest form? Well, let's say, plug in 108 divided by 12. Do you get a nice whole number? Absolutely. You get ln 9. Okay. And could we do anything with that? Nope. That's our final answer. All finished. So that's just some information that you need to know for today and for this week's logarithmic lesson. Let me know if you guys have any questions.